When we talk about data structures, we often talk about queues and stacks. We've already looked at queues previously, so let's look at a stack. Now, a stack behaves a little different than a queue. Where your queue was first in, first out, a stack is last in, first out. So let's look at a stack in a real-life example quickly. You go to your cafeteria at your university, and there's a stack of trays that you can pick up from. As you're walking up to get a tray to get your food, someone walks up and they have some freshly cleaned cafeteria trays. They put them on the top. The last one that was put on the top is going to be the one that you're going to grab. The next to last is going to be the one that the person behind you is going to grab. And so on this will go. Periodically, just as with a queue, you may add a bunch at one time, you may remove a bunch, or you might add and remove them independently. Either way, the last one that was added is the first one that gets pulled off. In computers, we do this with function calls. I may have a program that has a function that calls a function that calls a function. Well, how do I go back? Well, the last function that gets called, it finishes, it returns me to its calling function. As that function continues to process and finishes being called, I return to the previous function. And that's actually managed in a stack. In fact, we call it a call stack. And in some languages, this is a fixed amount. You can only have so many calls. Python is like this, for example. In other languages, you can have a virtually unlimited stack, and it's all a matter of how we store them. Do we store them in an array that's of a fixed size, or do we store them in a linked list or some sort of dynamic array? That is completely independent of the idea of your stack. Now, when you build a stack, you'll need to have your data that you're actually going to be storing. Once again, an array or a linked list is commonly used. And you'll need a couple of methods to work with it. Some of the common methods you're going to see are going to be like push, and push will add an element to the stack. And you can think of if I have a stack and I'm pushing an item on because maybe I need to compress that into a new list. Think of those cafeteria trays. A lot of times it's spring-loaded to put them up so that you can easily grab them. You have pop, which removes the top item. You have top, which lets you see what the next item is going to be used. And once again, you may have a count. Now, count is not required. It is optional, but it is something that a lot of people will use just so you can keep an idea of how many items are in my stack. Stacks are often used for converting between multiple data types. For example, converting between infix and postfix notations. We've already mentioned the use of function calls, and you'll find them used in other places as well. So understanding how a stack works is very important.